Noah is here tonight for part 2 of the Math SAT. He's going to go a little more in depth into the different sections and strategies. And I'm really excited. Week 1's session I thought was really, I learned a lot I didn't know before. So I'm looking forward to what you've got, Noah. You can take it away.
All right. Hi, Robert and everyone else. Hope everyone is having a great week. The plan for today is to go over the homework from last week and then to dive a little deeper into the content on the SAT math section. Before we dive into that, though, a little bit of news. The scores from the June test just came out, and something pretty unique happened. Basically, the test, the way that the SAT works, in order to standardize it and to make each month relate, is that they have this process called equating. And the point of that is to be able to connect and hold these scores and standardize them throughout. And so basically what happens on this most recent test is they threw out 4 questions across the test, which is a high number to omit and rarely happens. And it seems like overall this test was far easier than normal. And so if you check out Reddit and things like that, there's some articles, but a lot of kids are upset, rightfully so, because they were getting up to 10 questions more correct this time around and were ending up sometimes with their scores going down. So it's worth bringing up now just because it'll be interesting to see if this was a fluke where the College Board sort of overcorrected for their own mistake, or if this is an attempt to recalibrate the SAT with the ACT. So diving into the homework. Last week we were discussing the techniques, which are primarily pin, plugging in numbers, and back solving. And so I gave you a few questions here that would allow you to practice choosing between which techniques to use. So taking a look at the first one, if x plus 4 squared equals 49 and x is less than 0, what's the value of x? Well, you could think, oh, I could just plug in numbers, for x and see what works. But that is, you're guessing and checking without putting a filter on. So that's not so helpful. So what if we try back solving? So before we even dive in, if we look at the problem and understand it, we see that x has to be a negative number, which allows us to eliminate a and d right off the bat. So right there, we went from a 25% chance to a 50% chance. But then the concept you want to use here is back solving, where you plug in both of those numbers, and sure enough, you see that negative 11 plus 4, negative 7 squared equals 49. So B is the correct answer. The next one, Garth has X books, which is 20 more books than Henrietta has. If Garth gives Henrietta 7 books, how many books does Henrietta now have? So between pin and back solving, because you have variables in the answer, back solving isn't helpful. So in this case, you want to plug in a number and take that number sort of through the ride of the question. So let's pick something random like 3. Garth has 3 books, which is 20 more books than Henrietta has. So already we've run into a place where that doesn't work. So now we have to choose a new number. What about something higher than 20? Let's pick 30. Garth has 30 books, which is 20 more books than Henrietta has. If Garth gives Henrietta 7 books, how many books does Henrietta have? Well, 30 minus 7 is 23. So now all we do is we go through those answers and plug in 30. And which one yields the correct answer? That's right, C. On to the next question. And by the way, I put in parentheses sort of approximately where these types of questions would appear in the test. So number 30 is intended to be a hard question. And it sort of makes sense why. You have all of these operations and it's percents, or decimals, which most kids aren't so comfortable with. And it seems right off the bat incredibly complicated to try and deal with all of those decimals, and you're going to have to flip and do this and substitute. So this is an example of where it's perfect. There's really no harm to taking the 5 seconds to think, can I use either of these strategies? And in fact, you can. you can back solve because they're literally giving you the percents, and you can plug in numbers. So in this case, because you're talking about percents, you want to use 100. And so you take 100 through the problem. 100 decreased by 40% yields X. So what's 40% off? That's 60%. So you're left with 60. 60 increased by 50%. So what's half of 60? That's 30. 60 plus 30 is 90. What is 90% of 90? Or rather, what's 10% subtracted off of that? 90 minus 9 is 81. Because you choose 100, it makes the last part of the problem particularly easy because you're just comparing 81 back to 100. There's no extra steps. But that's a problem that would take a considerable amount of time doing all of the algebra. Now, it requires you to have some facility with dealing with percentages, but it's a far easier path to get a question that you're not supposed to get right. Moving on, if t cannot equal 0 and s equals 1 over t, which of the following must be true? So I'm pretty sure I can rule out back solving because there are variables in the answer. And if, say, you don't want to, you're not comfortable with the substituting, you can plug in a series of numbers. So let's say we make it 2 and 1/2. Because it's the reciprocal. Then you want to just plug in those numbers of s and t throughout all of them. And you'll find that you can eliminate 2, but that leaves 2 answers left, A and D. And so this is one of those examples of PIN where you have to plug in more than once. And it's good to, when you have to pick an additional number, it's helpful to think of a 1, a fraction, a negative, or 0. Those are usually, if you pick those right off the bat, there are times that they won't narrow down as fast. But if you find yourself having to use PIN more than once, then those are usually the numbers that will help distinguish and take care of that pesky additional answer. In this case, the correct answer is D. Let j, k, and m be integers where j is greater than k, which is greater than m, which is greater than 1. If j times k times n equals 120, what is the greatest possible value of j? So this is one example. You could start with PIN. You could just randomly guess, but again, that's not filtering your decisions down. So back solving seems like the right strategy. Now, in a case like this, when it's asking what is the greatest possible value of j, not that this will save a huge chunk of time, but when it's talking about greatest possible values, you usually want to start with the greatest values. So perhaps you start plugging in 60 first, or you could start with C, because if you remember, since they're labeled in order, if you pick an option in the middle, that'll give you a sense of whether you need to go higher or lower. So if you start with D, you're starting at the very end and you work across, or if you start with C, you're still starting on the higher half, but it's giving you 2 pathways. In this case, the answer was, in fact, which answer is this? B. Now, if 4 to the a equals b, which of the following equals 16 times b squared? So this is an example where back solving doesn't work, again, because you have the variables. And this is the type of question a student might not like because it requires substitution. You have to be comfortable with your exponent rules. You have to see that 16 is related to 4. So why don't we try back solving? And basically the point there is you plug in, or PIN rather, you plug in the numbers to see which align, and then you go through the answers. And when you plug in those numbers, does it yield the same answer? And in this case, it is C. Now finally, Rita has 5 fewer than 4 times the number of peaches that Sal has. If R represents the number of Rita's peaches, which of the following expressions correctly relates R and S? So this is a relatively easy question, but you'll find a lot of students don't like word problems at all, even if it's very straightforward. And a lot of students aren't really comfortable with the language in even the simplest of problems, particularly because Rita has 5 fewer than 4 times. We know that fewer relates to subtraction, but if you think about how you would set up such an expression, which is in fact A, the 5 fewer, syntactically it's coming first. So it doesn't totally relate to the process in the order that you would do it. So given that some students are uncomfortable with this, this is another great example for PIN, because it really just requires plugging in the numbers and seeing which align. And in this case, it's A. So diving into more of the content, the techniques that we've discussed, you can apply on all kinds of problems. They aren't just easy, they aren't just hard, they're not just algebra. They are helpful across the math part of the test. As the questions do get more difficult, there are some questions where it isn't so simple as just enacting one of those techniques. It might require you to still have some understanding of the concept, but these techniques will cut through a lot of the thicket of weeds. When we're talking about fundamentals, it really depends on how much time you have with a student. If you're really working with them for 2 months or a 10-week period working up to a test, I usually try to rely mostly on SAT materials, the published stuff, because so much of this is getting them into game mode, where you're throwing the questions, type of question they're going to see in the context they're going to see it. So it might be tempting to not talk about the math fundamentals, but so often it's sort of the blocks in their memory or how hard they've worked on this stuff that leads to the incorrect answers and just the careless errors. So if you have more time with a student, there is quite a bit of value of really going over, what is an integer? Having well, what's 0? Well, it's even, isn't it? Talking about factors, all of these things, again, it's up to you based on the time you have and the student you're working with to determine how long are you really going to spend on, okay, an even number times an even number is an even number. But there is value in, if you have the time, of things like remembering your squares and just seeing all of these relationships to know, what are the division rules for something like 7. They're never going to be tested on so specifically, but part of what we can do as tutors is, looking back at these problems, we have a clearer sense of where a student is going to go wrong than the student does, because they're still learning. But if we can create more pathways for them to see, to know that, 729 has a relationship with 27, which has a relationship with 3, as they're reading a problem and getting a sense of how to do it, they're going to see those connections and be tempted to want to use that information to their advantage. And oftentimes, those patterns are there deliberately and not to mislead. One particular topic that I found most students are not comfortable with, but that can be particularly helpful, is the prime factors with prime factorization, because that it's helpful with factoring polynomials. It's particularly helpful with everything with fractions, which is another area that students are very uncomfortable with. Yeah, on the topic of fractions, if you are going to dive in and really do review or worksheets, fractions and decimals are a good place to look. That's a lot of the reason why students are overly reliant on their calculator. A lot of the time, this is one subject that, even though they might have learned it a million years ago, they often never really learned it very well. So I would finding common denominators, compound, or particularly with division. Kids get thrown with the whole reciprocal thing. And when you have a compound fraction, which is like a fraction over a fraction, that totally throws them. That's a problem I've seen kids have that many years after they've learned it. And they also, a lot of students fundamentally don't understand that sort of the fraction bar means division. So I would say for the fundamentals, placing attention on fractions and sort of what they are and what they do and how to do it is a valuable way to spend the time. Also, ratios are important, usually with tables or equations talking about direct and inverse proportions. A tip that often comes up: to avoid mismatching units, always write the fractions with the quantity you're looking for first, then set up a second fraction with matching units. a lot of students, even if they are good at math, the way that we are often taught math and it's reinforced is we sort of learn a brute force method and we look for ways to apply it. We're not really thinking conceptually about the math we're doing. So I found that with these types of problems, the more ways that you can make these problems seem like puzzles for the student to solve and that you're giving them tools or methods of solving them, I found is particularly helpful in sort of getting them on board. Units are units aren't something that should be missed because you can literally always make sure they cancel out. But a lot of students are, it isn't necessarily intuitive. So it is worth having those conversations and setting them up with ways that encourage them to cut down on these mistakes that shouldn't be missed. All of these equal signs. It is worth talking about sort of the language of math. Across the board, students have issues taking, the numbers and putting words to them. And if you really go through the tests, you'll see that the questions are structured syntactically in very precise ways. And oftentimes the way that they're structured to a tutor indicates, what they're looking for and what the answer typically is. And you can see patterns. And perhaps it's worth going through the 8 release tests and grouping them to show your student, listen, this is how they ask it, and we can sort of define. When it says what, that means a variable. When it says is, that means equal. When they say percent, that means it's out of 100. These are things that are intuitive, but oftentimes kids in these classes really haven't taken the time to verbalize the connection between the words and the math. And so that's one place that the tutor can be particularly helpful. Exponents, combining bases. The rules are simple and straightforward. I think it's best to, have a quick lesson on it, have all of them in one place, so the student can refer back and get the whole lesson in a couple of bullet points. Absolute value is another one that I think is worth having discussions with because students aren't always so comfortable with the concept. The example I usually give is if you're in a car on a unicycle or whatever, if you pedal forward 20 feet and then pedal backwards those same 20 feet, what have you traveled? If you're talking in a positional sense, you haven't moved, but if you're talking total distance, which is absolute value, you're talking the distance there plus the distance back. Moving on. Here are just a couple of examples of the types of questions you would see with ratios. I don't think it's so pressing to go through them, but it's just to give you a sense of how these types of questions will manifest themselves. And they follow pretty predictable patterns. So some practice for the fundamentals. If 5 to the 2x plus 1 power equals 125, what's the value of x? I left the answers off of these, but these are the types of questions you would see. And this is another great example where, again, not that you have to do anything crazy, but if a student does know that 5 cubed is 125, if that doesn't require any finagling on the calculator or something, that makes the problem very straightforward and clear to understand. The next question, it's really just, it's units and then it's division. So if you know how many, if the division rules of 5, what numbers end in 5 and what does this number end in? It's a very simple problem. An example of percentages and these ratios. The problems are straightforward. I guess in terms of how to practice, again, I wouldn't take too much time just doing straight worksheets on this material unless you really have the time, because they often won't be tested. I mean, clearly there are multiple steps to it. So the main section of the SAT is Heart of Algebra, and over half of these questions can be done with the techniques, pin and back solving. And problems that are swimming in variables are good candidates for both techniques. If a question is variables in the choices, it doesn't matter what their values are, so we can use pin. If a question asks you for the variable or value of a variable, values the keyword, you can use back solve and test the choices for that variable. Like I said earlier, you still need to know the algebra, and the techniques won't work on every question, but the techniques can often save time in trying to get to that answer. Have a discussion. Yeah, again, so often, these kids have other classes. They're not focused on math. Most of them, if they need your help on this section, aren't, just inherent. They don't understand math. And so if part of the job of the tutor is to help clear the path for the student, I don't think it's outside the realm of appropriate. And I found it to be very helpful to really, sort of have these questions like, okay, what is the point of algebra? Like the point is to take these big quantities and to abstract them and make them easier to manipulate. And to have a discussion, okay, so what did you learn in Algebra 1? And Algebra 1 in its entirety is more or less about lines. You're learning how to take a bunch of different points that have one slope and how you can move them and how they interact and how they can cross with other lines. Even though something like PEMDAS, a student might say, oh, yeah, I know that. Fundamentally, if a student has an issue with algebra, in my experience, it fundamentally goes back to PEMDAS. They don't understand that what PEMDAS is sort of the manual that you carry. I mean, it's the order of operations. And so for some students, it's really worth just talking through that and showing examples, because if they don't have a sense of, if that is a foundational issue with algebra, where they might conceptually understand the higher level concept, like, okay, I take this thing and I add them. But if those foundations aren't there, they're going to be lost. So it is worth, whether you can deduce it from their diagnostic test or just watching over their shoulder, if you get a sense that their facility with algebra, the issue is coming from PEMDAS, that's something you need to nip in the bud right away, because Heart of Algebra is the most important and really the foundation for this test. So yeah, Algebra 1, Heart of Algebra, is writing equations. It's setting them equal, systems of equations. You can also see inequalities. When it comes to that, it's worth discussing when the signs flip. Typically when you're multiplying or dividing across with a negative sign, and then to show them the special cases, like when you have multiple values being compared. If one sign's going to flip, so is the other. Those are some of the nitty-gritty details that students don't typically remember, and that's what they are often, that's what these questions are testing to see. Do you know that difference or not? Here's an example of a question which, there's a lot of words to it, which will naturally stress students out or turn them off. But the gist of it is, okay, here's this equation. What's the 30 mean? So you're just putting words to what does this equation mean? And I think in this case, yeah, the number in front of the variable is the rate. It's the slope. It's the rise over the run. It's a relationship of y and x. So it's 30 books per hour. There's a wide variety of ways that they're asked. This is relatively straightforward. Sometimes it's not couched in language and it just wants you to compute. Frozen. Okay, here's an example of a system of equation, which is another topic that students typically it's worth going over the 3 strategies of how to solve them. But in a case like this, this is directly from an SAT. Here's a great example of being able to use the techniques to your advantage, because, okay, let's say I don't, all things considered, it's a relatively ugly system. They've switched out the or they've flipped the variables, but then they'd want you to multiply and add them and cancel out and all of that stuff. And maybe I don't remember that. But in this case, I can back solve because all it requires me to do is to pick one of the choices, take the x, plug it in, pick the y, and do the equations work. When it comes to system of equations, though, it's typical that plugging in some of these values will work for one of the equations, but not the other. That's typically the shortcoming, or where people make the mistake with systems. So you can back solve and plug those numbers in, but you have to make sure to use it on both. And in most cases, that's often faster than solving it the proper way with systems. The next section is Passport to Advanced Math, which is an unnecessary title. It basically means Algebra 2. So if everything that's hard of algebra is linear and related to lines and how they move and interact, then we're talking about higher functions, the degrees of 2 or higher. It's typically focused just on degrees of 2. But you see multiple variables, you're talking about function notation, which is, f of x or f of g of x and problems like that. This is where polynomials come in, foiling, factoring, difference of squares. This is usually worth reviewing because these types of questions can come up in word problems where you have some make-believe function. And sometimes it is very straightforward of, factor this. I've found that this is another area where students usually need to review, but it's easier to also frame these as puzzles because there is sort of that game element of that these have to add and these have to multiply. Difference of squares comes up in a bunch of different forms and is something that they should know. A difference of squares means this. Dividing polynomials in long division doesn't come up a lot. I wouldn't say that it's essential, but it's one of, but it comes up a fair amount. And I found most students are not totally comfortable with this, or they don't remember all of the rules with remainders and things like that. So depending on where your student is on the bell curve, if she's already toward the upper end, that is one of the rare topics that comes up more frequently than the others. So I would say that is worth paying attention to. And again, since you're talking algebra 2, if you've had sort of the conversation, what is algebra with the lines, it's worth talking about the quadratic formula. Not that they're ever going to have to derive it on the test, but make sure they know the algebra behind it. That they understand the series of y. It's worth talking about the discriminant. They're never going to be tested so bluntly like what is the discriminant of this, but if they understand what the b squared minus 4ac is really doing, what it's telling, there are many questions where the knowledge and awareness of what the discriminant says can save a lot of time with guessing and checking and reducing the inside radical and things of that sort. Exponential growth comes up a fair amount, as do logarithms. Here are some examples, relatively straightforward. Something here are two quantities and FOIL them out. Do you know how to do that? Here's another example that's slightly more abstract. It's asked, do you understand the processes that are going on? Which if you have a minus times or a negative times a positive, you're going to end up with a negative in front of the constant. And you have to know that they add up together. Oh, here's an example of what I meant by functional notation. And here is another example of having to take factoring and applying it to, its roots. So though graphing isn't it's not specific to one of the sections on the test. Graphs appear in all shapes and sizes, typically drawn to scale. And here are the topics that usually come up. Again, unless it says that it has been explicitly is not drawn to scale, you can assume that it is. So if an angle looks obtuse, assume it's greater than 90 degrees. If it looks acute, so on and so forth. Talking about the Pythagorean theorem, being able to relate that to the distance formula And then eventually being able to relate that to circles is particularly helpful, because a lot of kids want to just memorize something, but this, if you have the time, is the time where you can sort of connect those pieces and remind them, like, oh no, there's actually sort of a logic to what's happening here. Because I think more important than memorizing something is understanding how it works, because even if they, are stressed out in the moment, they can take a breath and they can, recreate the work that you two have done. Inequalities come up all of the time. Something a lot of students don't remember or didn't learn is the trig negative b over 2a, which is how you determine the x value of the vertex of a parabola. So in the general function ax squared plus bx plus c, that's negative b, the middle term, over 2 times the first coefficient. And that gives you the x value of the vertex. And the way that you would then find the y value of that vertex is you would plug this in to that equation. There are all kinds of questions that are asking whether it's rearranging the form of the equation to put it into vertex form or things of that sort. Knowing the vertex is incredibly important for parabola questions, and negative b over 2a is typically far easier than completing the square or doing any of those extra steps. So if your student has seen it, definitely review that. If they haven't seen it, I think that's one of the examples of where it is worthwhile teaching them something new, because it will only be helpful. With circles, really most of the battle there is just knowing the equations of it, and knowing that it equals r squared. And then similarly, you'll see across the board just how functions move. And so a lot of students aren't clear that typically what's inside the argument, what's inside the parentheses affects horizontally, and what's outside is vertical. Because they sort of get confused on which is which, and then they forget, okay, but do I flip the sign on this one or that one? So that's another good place to come up with those 2 bullet points and really solidify it down for them. Here are examples of the types of questions you might see related to graphing. They can be super straightforward, like what is the slope of this? A lot of questions that come up demand a facility between the 3 or the different forms of an equation. They'll give you one form and they will expect you to change it properly, and in the answers they will give you sort of a bunch of the things they would expect you to do if you don't know how to do it. So it is like with lines, you have general form, you have slope intercept form, you have point slope form. A lot of people forget point slope form, jumping back. So that is another area to hit hard. Here's some more examples of the types of things you might see that are graphing related. Obviously, if these come up on the calculator, you can use the visual graphing function to your advantage. For some students, seeing a parabola intersect, y equals 12 or something is easier than them making the connection, oh, I set the 12 equal to that equation. For circles, like I said, knowing that equation is usually the only, if you know that equation, you can usually do any problem related to a circle. So more important than just making them memorize it, which shouldn't be too arduous. It's basically, 2 perfect parabolas, but connected back to Pythagorean theorem and the distance formula, and talk about how what happens in this direction doesn't affect what happens in that direction. Problem solving and data analysis. I think I went into it a reasonable amount last week, but this is where all of the language issues come up. When I was working with student athletes, this was by far the hardest part for them to do the math, but it was the translating what were in tables and just sort of the reading comprehension is what the main issue is. And I've seen that it's an issue for students all across the board, because again, you want to frame it to, these are kids who think the weight of the world is on their shoulder. all of the classes they're doing this in addition to all of their classes. And so they're often just trying to get the homework done and stuff like that. So it's typically they'll see, you want to point out when these don't make them feel bad, but you want to implore them, you want to let them see that these are mistakes that they're making and that are easy fixes. Again, like the number of times they'll change axes on you, and the increment in the X direction is different from the increment in the Y, and that's the only reason why people are getting it wrong. So yes, it's worth reinforcing the topics you're discussing with them with reading comprehension, or to bring it to the ACT, sort of the science topics, and encourage them that there's a lot of things where it's really, if they're following along and they pay attention, they're doing everything else right. It's worth clearing up positive and negative association or correlation. Box and whisker plots usually don't come up, so you don't have to worry too much about them. Other than that, the graphs are usually pretty standard. Maybe the students haven't worked a ton with frequency tables, but there's a fair number of them throughout the released exams that you can make whatever point you would want to make with them. Stats comes up a fair amount, which students have seen. Sometimes they haven't seen it formally. A lot of curricula choose different times to introduce stats. It is helpful talking about skew, though, when it comes to it, meaning, you know, skew is related to the tail. So if the tail is on the left of the distribution, it's left skew, and vice versa. Particularly useful is to talk about what direction, when you have a skew, what direction do the median and mean go with relation to each other? Because those questions, though not specifically asked about, are often the trick to making those particular problems simpler and more straightforward. And the additional topics, again, this is the smallest section. There's only 6 questions asked throughout. So yeah, typically these questions, sort of like equations with circles, if you get the main point of them, that's all it really takes to get the question right. Like an example of complex numbers, maybe they would ask, you know, they'll find a way to dress it up, but what's I to the 2018th? So all it's really asking is for you to understand, okay, the powers of I repeat in cycles of 4, and then I would have to use division rules to find that remainder. Conjugates or complex conjugates come up every now and then, but they're really not the crux of, you know, what would be asked with complex numbers. The same thing with trig. If you know SOHCAHTOA, if you sort of have a general sense of, okay, I know which, you know, cosecant is related to this, and tangent is related to this one, and sine over cosine equals y over x. If you have the general sense of those principles, they're not going to ask ridiculous half-angle formula, things like that. So again, depending on the student you have, if she is on the upper end of the curve, it is valuable to go over these topics, because someone who's a sponge who only needs to see it a few times and just has to be refreshed a couple of moments before the test will go in and get it right. Overall, though, these are, it really depends on your student. Ideally, you can get through them, but this is not where I would focus the majority of my time. They are given a formula sheet that gives volumes and areas and things like that. It's worth being aware of what they will see. And again, guesstimate with these questions. When you have pictures, unless it says it's not drawn to scale, assume it is, and use that to make educated guesses to make the numbers simpler. And it makes life a lot easier. So those are sort of the sections of the SAT math. Again, the main techniques we have talked about that work across all of them are back solving and PIN. The main sections, content-wise, are Heart of Algebra, which is Algebra 1, Advanced Algebra, which is Algebra 2, meaning parabolas and things like that, problem solving and data analysis, which is graphs and reading comprehension and ratios and percentages and real world applications of the material. And then the last one is additional topics, which is sort of a little bit of geometry, a little bit of higher algebra 2 concepts, but they don't go so deep into that. I thought I would maybe open it up to questions if anyone has.
I actually was wondering, you know, when you're talking about the fundamentals and material, do you have any resources that you know, because I know with students your time is limited, but if you're a tutor, let's say, and you don't have a math background, right, and you want to commit to sort of building those fundamentals, do you have any resources that you recommend for our viewers watching at home?
Yeah, I guess there's a lot of material that's out there. I think a lot of material isn't so great. I like the ideal scenario is that the types of questions they're doing are really from SAT tests, because you don't know who calibrated with those study guides. Khan Academy is partnered with the SAT. They have great resources. I've used them to brush up plenty of times. In an ideal world, a student is using that in tandem. It might render the tutor obsolete, but I mean, Khan Academy is a great resource. Another thing, not that I spend my time on it often, but there's an SAT Reddit thread, which is where I was getting all of the information about this June test debacle, of course, because that's where all of the angsty kids go.
Got it.
But it is a good community where there's like a lot of PDF. Like, the resources are out there. But in terms of what I like to do with the student, particularly if it's on a shortened schedule, if it is like an 8-10 week sort of thing, I really want to be working with the SAT materials. The ACT is better in that respect because it has changed less. But there's 8 tests on the SAT. It's rare that a student is really getting through all of them. So if you're only working for a relatively small window, it shouldn't be difficult to be able to pull, like if you say, okay, I want to do long division, among those 8 tests, there's probably 5 or 6 questions there, or at least enough to give you a sense of how to construct your own question with just slightly different numbers.
Yeah, that makes a lot of sense.
Anything else?
I don't know if you have your chat window open. I actually don't have mine at the moment.
I do not see any chats.
All right. Yeah, Robert actually has a math background, so I was curious of his perspective on anything, you know, that he was wondering about. But I think my only other question is, I don't know, kind of a general question is, you sort of mentioned like the high achieving students and, you know, opportunities and challenges for them. What would your advice be for those classic math anxiety students? Those students that have, you know, math anxiety and now find themselves studying for this, you know, very time driven exam, and, you know, kind of how would you handle that?
Yeah, so I guess like the most important thing there is the anxiety is one thing, but then I guess, is it a time issue? If you can assess if it's a time, typically timing is more a problem with the ACT. So first you want to get a sense of, is timing the main issue for my kid with the SAT? If that's the case, then I think it is valuable. It's harder to do if you're doing it remotely, but there is a lot of value of not an entire section, but okay, we're going to do the first 8 questions, you know, in this amount of time. You're going to set the timer, at least in little chunks, and watch them do their work. I guess this works. I mean, this is the case across the board. But if you can watch them doing the math and you can see where you can see them, oh, they put this answer, then they changed. Or it is valuable to observe them to see where their issues are with the anxiety. To a certain degree, yes, you have to be the head shrinker and you have to clear away all of the you have to clear away all of the anxiety that isn't actually math related to them. If it's an issue about timing, then I would hit that element harder. But that's why I think these conversations sort of at each level of having a conversation like, what is algebra? Like most kids, I mean, most people just aren't talking about that. Again, the students who aren't the best at math very rarely have like any type of conceptual scaffolding of the math they're doing. They sort of are doing it brute force of like, I learned that I do these steps on this type of problem. So if you can connect intellectually, conceptually with them, that is the way that I've found most helpful. Usually if they have anxiety, it's those fundamentals. It means that they're not comfortable with fractions and with all of those nitty gritty. So even if they do understand the higher level thought, which is I take these things and combine them in some way, if they're not sure of how to handle the individual elements, then that's going to, infect the rest of their mindset.
That makes a lot of sense, and that's very helpful. That's all I've got. I don't know if there's anything else from Robert, but otherwise, just going to say thank you so much. That was awesome.
All right. Anything, Robert?
I'm opening my chat.
I'm not seeing anything, but.
Well, he had asked before, what does PIN stand for? And I said, yeah, but he figured it out without our help. But all right. I think it's a great stopping point, and I just want to thank you again for an awesome second session. I'm looking forward to digging into the ACT next week.
Likewise. See you guys there.